we are grade 7. Today, we will focus on the significance of each paper, the methods used, their weaknesses and suggestions for improvement. Additionally, we will raise some questions for the authors. To introduce the non-recursive cluster scale graph interactive model for click-through rate prediction. The paper introduced the NRCGI model to reduce computational cost for click-through rate prediction, and this paper discusses the challenge of balancing computational efficiency with predictive accuracy in existing models. It highlights the benefit of employing graph-based models and introduces the concept of non-recursive graph convolution. The strength of this paper is the experimental method of this paper outperforms state-of-the-art baseline in 3 public datasets and 1 industrial dataset while maintaining efficiency inference. And I'm going to introduce 2 methodologies used in this paper. First, the non-recursive cluster scale extraction. The key concept of this method is below. The model begins by clustering users and items on a global scale. Then, each user and its item is assigned to a specific cluster. Thirdly, for each cluster, the model aggregates the graph information at multiple levels for neighbor interactions, aka the hubs. And finally, once the clusters are defined and graph information is aggregated, the model pre-aggregates these embeddings. So, the benefit of this method is below. First, the clustering and pre-aggregation steps significantly reduce the number of interactions that need to be processed during the prediction phase. And second, it simplifies the graph structure, making it more manageable and less computationally expensive to extract useful features from the graph data. And the second methodology is that the graph interactive prediction. The key process of this method is listed below, and the benefit is first, it allows for detailed and specific interaction modeling between different layers of graph embeddings, providing a rich set of features for the prediction test. And second, the attention mechanism and the explicit interaction construction enable the model to focus on the most relevant features and interactions, this improving the accuracy and efficiency of the prediction. And later, I'll share about the weakness and improvements in this paper. First weakness we observe is the scalability. While the NRCGI model is designed to handle large datasets by reducing computational complexity, the scalability to extremely large datasets isn't explicitly tested or discussed in this paper, and the performance in such scenarios remains uncertain. For the improvement, we think it can conducting tests on even larger or more varied datasets. And the second weakness is that the model operates based on pre-aggregated cluster embeddings, which might not adapt well to real-time changes in user behaviors or new items. And we think the improvement should be integration with real-time learning, such as incorporating online learning components that can update the embeddings based on new interactions without full retraining. And finally, is my 3 questions regarding this paper that I would like to ask the authors. And first, regarding model generalization, I would like to ask, in your paper, you tested the NRCGI model primarily on datasets like Movie Lens and Amazon subsets. What do you anticipate the model would perform on highly dynamic datasets, such as real-time social media interactions or streaming data? where user preference and item characteristics can change rapidly. And second, concerning model scalability and deployment. While your NRCGI model reduces computational complexity through clustering, could you elaborate on the computational overhead and scalability of the clustering process itself, especially in very large datasets? How does the clustering mechanism handle new users and items that are continuously added to the system? And my third question will be regarding the future deployment. Are there any plans to extend the NRCGI model to incorporate real-time learning capacity that would allow it to update its prediction based on new data without full retraining? If so, what might this affect the model efficiency and accuracy? And this will be my sharing. Thank you.
Let the LLMs talk, simulating human-to-human conversational QA via zero-shot LLM to LLM interactions. This paper will discuss how LLMs can simulate human conversations using zero-shot interactions. First, let's address a significant challenge: the high cost and inconsistency of maintaining a large team of annotators to generate numerous conversations. Human annotators often struggle with unfamiliar topics. However, LLMs can handle a wide range of subjects, like experts. Therefore, finding automated ways to create these conversations is essential to reduce the reliance on human annotators and enhance efficiency. To tackle this challenge, the paper proposes an innovative approach that leverages the interaction between two LLMs on specific topics. The first LLM acts as a student, generating questions to explore a given topic, while the second LLM plays the role of a teacher, answering these questions with additional information, such as a comprehensive text on the topic. This approach offers significant benefits. The teacher LLM provides longer, more accurate, and comprehensive answers, resulting in high-quality responses. Meanwhile, the student LLM asks a variety of questions, covering many aspects of the topic. This thorough exploration makes learning more effective. In the methodology, the authors set up an experiment to simulate information-seeking conversations between a student and a teacher using LLMs. The student LLM generates questions based on limited information from a Wikipedia article, while the teacher LLM provides answers using the full article text. The process works as follows. The student LLM starts by generating a question using given instructions and limited information, such as the topic, background knowledge, or section header. This question is then validated and refined if necessary. Once validated, the question is sent to the teacher LLM, which has access to the full article text. The teacher LLM generates an answer based on the appropriate text spans, validates it, and sends it back to the student LLM. This iterative process of question generation and answer validation continues, ensuring both models work together to thoroughly explore the topic. They also use a well-known dataset to evaluate the approach and ensure fair and accurate responses. The teacher LLM selects appropriate text spans as answers, while the student LLM explores the topic by asking diverse questions. This interaction continues until predefined criteria are met, aiming to reduce reliance on human annotators and improve the efficiency and consistency of the conversation generation process. Despite the advantages of this model, there are several limitations. Firstly, only GPT-4 consistently follows instructions to generate reasonable conversations, limiting the overall effectiveness of our pipeline. To address this, we need to diversify our model used by exploring and fine-tuning other language models, enhancing the system's flexibility. Additionally, language models can exhibit various biases, impacting the quality and fairness of the generated conversations. Implementing advanced bias detection and mitigation techniques, such as training with diverse datasets and using fairness-aware algorithms, is crucial to ensure the model's reliability and ethical use. Lastly, the manual construction of instructions is time-consuming and inefficient. To improve this, we should develop more advanced and efficient automatic prompting strategies. Techniques like reinforcement learning, where models learn to generate effective prompts through trial and error, or meta learning, where the model learns from previous successful examples, can significantly enhance the system's efficiency and scalability. These improvements will help us create a more robust, fair, and efficient conversational model. In this paper, the student LLM can ask about many different topics, but it is important to ensure the conversation flows logically and makes sense. I'm interested in specific ways to ensure the student LLM not only asks a variety of questions but also maintains a clear and logical conversation flow. Secondly, LLMs often face challenges when dealing with highly specialized topics due to limited training data, which can hinder their ability to provide comprehensive and accurate responses. This limitation is a significant obstacle in achieving high performance and reliability in conversational QA systems. To address this, I would like to ask the authors about the specific approaches that can be developed to enhance the adaptability of LLMs in these scenarios. This paper uses standard metrics like correctness, completeness, and naturalness for evaluation. However, this may not fully capture the nuances of human conversation. Therefore, my third question to the author is, how can we improve evaluation metrics for conversational QA systems to better capture human-like dialogue and accurate information retrieval?
And I'm going to sharing the TCCM time and content aware casual model for unbiased news recommendation. And first, I'll do the introduction. This paper introduced the time and content aware casual model, TCCM, and the challenge it wants to deal with is a popularity bias in news recommendation system, while often result in a loop where popular news gets more exposure. And the strength of this paper is it proposes a TCCM model to more accurately estimate the news timelines and news popularity, And ultimately, TCCM outperforms a range of state-of-the-art techniques and well-known benchmark datasets. And I'll share about the methodology it proposed. This is the graph of causal graph proposed by TCCM. The author used it to explain the relationships in news recommendation, highlighting how news attributes like popularity and timeliness impact user interactions. And the author also explained how they apply causal interventions to adjust the influence of popularity, ensuring that recommendations are less biased and more personalized. And the benefit of this section will be: first, bias reduction. Causal interventions allow the model to manipulate the influence of certain variables like news popularity, enable the evaluation of the actual impact on the recommendations. And second, enhance recommendation integrity. By adjusting the weights of various factors such as the type of news and its inherent popularity based on content, the model can provide recommendations that are more reflective on genuine user interests rather than skewed by external bias. And the weakness and potential improvement of this paper. First, the model primarily used entities and keywords from the news content to estimate popularity and relevance. However, this approach might overlook the deeper semantic and contextual nuance of the news content. And the improvement we can think of is to integrating more advanced natural language processing techniques such as sentiment analysis and contextual relevance. And the second is, while the paper extensively used traditional metrics like AUC, MRR, and NDCG for evaluation, it may not fully capture user satisfaction or the qualitative aspect of news recommendation. So, for the improvement, we can expand the evaluation framework to include the metrics such as diversity, novelty, and fairness. And this will be my 3 questions that I would like to ask the author. First, regarding impact of content depth. In the current model, you estimate news popularity based on entities and keywords. What do you think about incorporating deeper content analysis? Would integrating such features into TCCM enhance its performance or present new challenges? And second, regarding model adaptability. Your model primarily relies on historical interaction data. How might TCCM adapt to real-time changes in user preference or external factors that influence news consumption patterns? What methodology would you consider? And finally is the generalization across different contexts. Because these experiences are based on a dataset from Microsoft News, could you share insights on how TCCM performs on datasets from different cultural or linguistic backgrounds? How might this affect its debiasing capability? This will be my 3 questions, and thank you very much for listening.